In this video, we're going to talk about classes and methods. Now, this particular topic is not part of the chapter. It will be part of the next chapter, so this is kind of a preview look. I'm just going to go over some basic stuff. Classes are ways of grouping functions, maybe your variables or constants. And classes are really easy to make. They're a way of organizing code and reusing it. Very similar to the way you use a function to group one or more programming statements, classes can group one or more functions. So let me just give you an example. Same code as before. I have my variables defined, and I go through and I then make a class I called Math Processor. And you indicate, as you'll see later on, which which class you want to inherit code from. Then a colon like you would a function. You can use a document string like you would in a function. And then you define your function. So here's my add values function. Now, I can define many functions, hundreds of functions, one function, 10 functions, whatever. I'm going to decorate it with this command called static method. Now we'll talk more about this in a later module, but basically it allows me to call the function by using a dot notation of the class name dot the name of the function I want to use. And I put that right in front of the function add values. Later on, when I want to call it, I use the name of the class and then the name of the function. Other than that, it works the same. So it's just another grouping mechanism. Let's take a look at how I might do this. So let's see here. I have decimal answer none. I don't want to do globals. I don't want to use globals. I just want to return a value. Something nice and simple. Let's see. The value is decimal answer. Oh, I got to capture the value. Decimal answer equals add values. Okay, that should do it. Let's see make sure I haven't broke it. Okay, sum of 10 and 5 is 15. Seems to be working. And let me pause there so you guys can take a look at the code. I think I'll take a few comments out to make it a little bit clearer. First argument, second argument, results of the processing. First argument, second argument, results of the processing, and just prints out the answer. Okay, so now what I want to do is I want to wrap a class around my function. So I do that by going through and just making up a class name, and I just make up something like math functions. And I'm going to indent this. Now I should be actually going through and putting in object to indicate that I'm going to inherit from the object class that is part of Python. It basically provides a basic template that you can use for your classes. And we'll talk about this inheritance. It's the third pillar of object-oriented programming later on. Not in this module, but in the next one. So that should work like that. The only thing is add values now needs to be referenced by using the name of the class. And now it's happy. Let's see if it runs. Cool. Now you should decorate it with the static method they call this an attribute. The static method attribute to define that yes, you want to be able to call it with this dot notation. Again, I will explain in later next module, we'll talk more about the options. Actually, I'll explain it a little bit later in this video, come to think of it. I'll share the contrasted version. But anyways, you can see it's working. With or without it, this would be the correct way of doing it if you want to call it directly. And if I had another function, let's say one that did division, I just put that together. Pretty easy. And now I'd have two. I could go ahead and call that. So this is a really easy way of grouping code together. And the nice thing about it is, when you copy the class and you move it into another file, whatever that file is, it's encapsulated. Everything is in there so they can be reused easily in this other program. And that's a good thing. I can use it very differently than I did in the other one, but it still works. It's reusable. Oh, okay. Apparently I closed that other file, I deleted that other file, and so it's not there. But that would be the concept. I'd be able to reuse it wholesale as a collection of one or more functions. So let's take a look at another example here. I've got this class. I call it the customer class. It's holding information about customer data, like maybe the customer ID and maybe the customer's name. And maybe I make a function up that will go through, and when you ask for the data inside of here, I'll print it out as a string. I'll call the function toString. We've seen functions like this called on other classes. Now, when I do this, I'm going to use the word self. And using the word self indicates that I need to make a copy of the code for the class and use the copy, not the original. In the other class we were just looking at, Math Processor, in that class, I'm not making a copy of the class first to use the copy. I'm just using the original. This is part of having the static method. I'm not using the word self here. Instead, I'm just using that directly. I'm not making a separate copy. And this makes sense in places where your class is all about doing some kind of processing. But what if your class is about holding data? Customer is not about processing something. It's about holding customer data, such as the ID, the name, the address, the phone number, and the like. By putting the word self there, I indicate that I want to use it as an object instance, which is a fancy way of saying I make a copy of the code for the class in memory, and I use the copy, not the original. I can declare these values as being fields, fancy word for variables inside the class, and then interact with them. Let me show you an example. Now, we will be going over this topic again next module. This is just an overview, because it usually takes more than one time seeing this before it really starts to make sense. So if you're finding this hard to wrap your head around, it is perfectly normal. Don't worry about it. But let's see if we can get it. So I've got this class, I called it customer, and its job is to hold data. And I want a couple things going on. I want to be able to fill up the data and hold it, and I want to be able to present the data or extract the data out of it as a string in this case. So what I'll do is I will go through and load this up into memory when the script starts. And to make a copy of that class in memory, I'll use this syntax. Make me a new customer object. Then I'll be able to go ahead and set the value of the ID and name. And if I do it again on a different line, I'll get a new object in a different location and memory. Same code, different memory address. Customer 1, let's say, is at address 214. Customer 2 is at address 67. I'm just making up numbers. So I have two different objects which holds two different pieces of data. This is kind of handy. We've seen how you can use a dictionary to hold data. We've seen how we can use lists to hold data. We've seen how, let's see, those doggone crazy, devilish smart quotes. Oh, I hate you. Okay. We've seen how we can use tuples to hold data. We've seen how we can use dictionaries and lists to hold data. This is another way of holding data by making up a class, defining fields. Sometimes these are referred to as properties, but they're just variables. And making copies of the class code and then interacting with those properties or fields or variables, whatever the heck you want to call them. And I can also call the toString function, or as they would call it, a method, and extract the data out. And that's what I did here. This is a very common practice in programming, guys. And we will see this going forward in much more detail. But this hopefully gives you kind of a heads up about the topic. And in fact, to reinforce it, we're going to do a lab about this. So I will see you there.